Okay, let's start with today's class. So I was not able to take class Monday, so I'm going to take extra class for that this week only. Okay, I'll let you know about that class in the group. Okay, let's start with the class. We'll start with data structures from today. Okay, so let's see what is data structure, and how to learn data structures. So a simple definition of data structure. See, the definitions which I display in the PPT are just for the presentation. Okay, you can even refer the book for definition of data structures. Sahani book is available in the library. You can go with that or take the book, uh, get that book and go through the definitions. I'll even try to give notes for data structures. So don't worry about that right now. So only thing is you have to concentrate is the concepts which we are going to study. I may not follow the same exact syllabus while discussing data structures. So if I miss some topics in between, that doesn't mean that I'm missing them with the syllabus. I'm going to discuss them soon. Okay, so order may change the way I discuss data structures according to the syllabus, but we'll complete everything in detail. Okay, so let's start with the first concept, data structures here. Data structures, according to the definition of data structures, is very simple. Here, the definition which I have displayed: organization of data in a particular order is called as data structure. Now, what do you mean by data? That is very important. Okay, organization of data in a particular order is called as data structure, as the name itself indicate. Okay, so what do you mean by data? Anything which you store in the memory location is called as data. Whether you are storing a number, whether you are storing a letter, alphabet, or group of alphabets like string, whether you are storing some values, okay, any special symbol you are storing, everything which you store in the memory location is considered as data structure. That is very simple. Okay, data structure is anything which you store in the memory location, that is called as in a particular order is called as data structure. Sometimes while storing the values, you have to follow some order. You cannot simply random or you cannot simply store the data. You have to follow some order. In that order you have to store the values in the memory blocks. That storing of data in a particular order or organization of data in a particular order is called as data structure. Now, what are the tools available for storing the data? See, usually we have studied that I can store a number. For example, I can store 17 in a particular memory location. To store 17, I don't need group of memory blocks. I need a single memory block. Okay. To store 17, I don't need group of memory blocks. Only single memory block is enough. If I declare int a, in that variable a, I can easily store 17 because only one integer value I'm going to store here. That is not called as data structure because you are storing data, single data. So to store single data, there is no particular order. Is it correct? There is no need to follow particular order. So storing single value is not considered as data structure. Okay, storing group of values in a particular order is called as data structure. For example, if you consider storing some numbers in an order, for example, in storing numbers in ascending order, like 1 to 10. So you have to store all these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You cannot store all the numbers in a single memory block. Okay, you have to store them in different memory blocks, but all these memory blocks must be connected to one another. Clear? So that they can be easily accessed. That is what we call organization of data in a particular order. That is what we call data structure or data structures in C or C++ or Java or in any programming language. Data structures is same. Okay, it is not different in regarding or based on the programming language. So irrespective of programming languages, we are going to use the same data structure. Okay, some of the examples of data structures. So these are some of the examples of data structures which I have displayed here. Major example here is arrays. Okay, array is a data structure. Why do you call array as a data structure? Because in arrays, you don't store a single value, you are going to store a group of values or number of values. Okay, that is what we call data structure. When you store number of values in a particular order is called as data structure. So simple example or basic example of data structures is arrays. Arrays ಅನ್ನೋದು ತುಂಬಾ basic example data structures ಗೆ. Next example is linked lists that we will discuss soon. Okay, after discussing arrays we'll discuss linked lists. Next example is trees. Apart from that, these are the three main important data structures available. Apart from these, there are some other data structures also we are going to study. One is called as stack or stacks, queue or queues, then graphs or graph. Okay, these are some of the examples of data structures in C or C++. Now, this stack and queue, these two data structures can be created either using arrays or using linked lists. So remember, very important data structures which we are going to study are these two. Okay, arrays and linked lists. These are the two important data structures. Based on these two data structures, I can create some other data structures. I can use some other data structures called as trees, stacks, queues, and graphs. So stack method queues now, I can create stacks and queues either using arrays or using linked list. I can create trees mainly using linked lists. Okay, so these are some of the examples of data structures in C or C++. Now, why we have to use data structure? One main reason is organizing data in a particular order. That is first main reason, or that is the definition of data structure. What are the other reasons of using data structures in C or C++? So some of the major operations or some of the major tasks which we can do using data structures are these. Okay, so these are some of the tasks which we can do using data structures. First one is called as traversing, searching, inserting, deleting, sorting, and merging. Some of the major operations which we can perform using data structures or on data structures, which are based on data structures. Now, traversing is nothing but checking every data which is stored in group of memory blocks, or visiting every data. Or for example, if I'm using array, okay, displaying all the element of the array ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು what you will imagine, it is nothing but you have to display every element stored in all the memory blocks. So if you are displaying every element, you have to go to that particular memory block which has a particular element and display that on the output screen. This is what we call traversing. ಎಲ್ಲ memory block ನ visit ಮಾಡೋದು, ಆ memory block ಅಲ್ಲಿರೋ value ನ display ಮಾಡೋದು ಅಥವಾ check ಮಾಡೋದು. That is what we call traversing. Okay, so data structures ಅಲ್ಲಿ one major operation ಏನಂತ ಹೇಳಿದ್ರೆ traversing the data structure. I mean visiting every memory block in the data structure. Second operation, searching. For example, if I have stored 10 elements in an array or 10 values in an array, okay, so if I have to search a particular value which is stored in a particular memory block, that can also be done in data structure using an operation called as searching. You might have heard two important searching techniques in first year C programming subject, that is linear search and binary search. If you remember, two important searching techniques that we may discuss soon while discussing searching techniques: linear search and binary search. So linear search and binary search are the most famous searching techniques to search a particular value stored in a particular memory block. So second operation which can be done on data structures is called as searching. Next one is inserting. Okay, if there are some elements in an array or in a particular data structure, if I want to add one more value, okay, that is what we call inserting operation. Okay, if I have to add one more value either in the beginning or at the end or in between, so everything is called as inserting. Don't worry about right now, ನಿಮಗೆ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ don't worry about it, because we'll study in detail how inserting can be done in data structures, how searching can be done. Okay, in detail we have syllabus. So in detail, we'll study everything. These are just some of the major operations which we are going to use in data structures. So next concept is called as the next operation which we can perform is deleting. Memory blocks ಅಲ್ಲಿ group of memory blocks ಅಲ್ಲಿ ಅಥವಾ consecutive memory blocks ಅಲ್ಲಿ ಇರೋ elements ನ or values ನ delete ಮಾಡಬಹುದು ಯಾವ್ದಾದ್ರು particular value ನ. That operation is called as deleting operation, which is used in data structures. Sorting is also one of the major operation which can be done in data structure. ಕೆಲವು ಸತಿ array ಅಲ್ಲಿ elements or values memory group of memory blocks ಅಲ್ಲಿ values ಯಾವ್ದಾವುದೋ order ಅಲ್ಲಿ ಇರುತ್ತೆ. For example 17 1 27 2 26. If this is the order of the data values in the group of memory blocks, I can sort them either in descending order or ascending order. That process is called as, or that operation is called as sorting in data structure. Last one is called as merging. So I can merge the values in two different data structures. Okay, that is what we call merging. So we don't worry, we don't study much about merging here. These are the major operations which we are going to study is inserting, deleting, and searching. Okay, we'll study about them in detail. So this is what data structure is, or definition of data structure and examples of data structure is. The first data structure which we are going to study is called as arrays. If I am very good at arrays, it'll be easy for me to understand stack and queues. First thing, okay, arrays. If I'm very good at arrays, if I know everything about arrays, I can easily understand stacks and queues, because first implementation of or stacks and queues are majorly can be created either using arrays and linked lists. So adukoskara we'll study arrays first, then we'll study linked list, then we'll study stacks and queues. And before that, in the syllabus they have given string operations and all. After discussing arrays, we'll go with the syllabus, or we'll start with the strings which is given in the syllabus, then we'll continue our discussion with stacks and queues as soon as possible. Okay, so let's see what are arrays and how we can use arrays in data structure. That will be easy for stacks and queues. Okay, so I'll go a bit fast now, because we have already discussed arrays, I think, or if I have not discussed, I'll explain everything bit faster. So try to concentrate. Okay, so arrays andre enu, how we can create arrays, how we can use arrays. Okay, so here we don't worry much about two-dimensional arrays. Only type of array which we have to know is single dimensional array. So we'll concentrate much on single dimensional arrays. Then if time permits, then we'll start with matrices, that is two-dimensional arrays. Okay, so consider this example here. Int a, the memory block gets created. As soon as I write int a is equal to 1 anta vartashna, 1 will be stored in the memory block called as a. This is very simple. Okay, this is not called as arrays, because in this memory block a anno memory block ali, I cannot, instead of writing a is equal to 1, I cannot write a is equal to 1, 2, 3, because 1, 2, 3 are three different values which I am trying to store in a single memory block. That is not possible here in a single memory block. So this is wrong here. So what is the solution for this? Either I can write like this: int a comma b comma c, create three memory blocks and store all the values 1, 2, 3 in different memory blocks. A is equal to 1, b is equal to 2, c is equal to 3. But the problem is, if I have to store 10 values, I have to create 10 variables. It keeps on growing number of variables and number of memory blocks. See, one more thing. You can observe here, three memory blocks which are created, they have different address. Okay, 100, 400 and 700. So, and they are not connected to one another. So this is very important part here. And these memory blocks which have totally different kind of address, they are called as random memory blocks. Okay, the address here are totally not connected to one another. That is called as random memory blocks. So what is the solution for this? So what I'm going to do here is, instead of writing int a here, I'm going to write this int a of square bracket, within square bracket I'm going to write 3. This I'm going to pronounce it as int a of 3. Okay, a of 3. As soon as I write this line, computer creates 3 memory blocks which are almost connected to one another, group of memory blocks which are connected to one another. How do you say they are connected? See, you can observe the address here. Address of first memory block is 100. Address of second memory block is 102. Address of third memory block is 104. See, continuity is there in the address. That's why they are called as consecutive memory blocks. Here, these are called as random memory blocks. These are called as random memory blocks. These are called as consecutive memory blocks. Because address of these memory blocks is continuous. 102 because first memory block needs 2 bytes because of integer 2 or 4 bytes. I am considering 2 bytes here. That's why 100 101 2 bytes ಇದಕ್ಕೆ ಹೋಗುತ್ತೆ. Second memory block 102 ಇರುತ್ತೆ. 102 103 103 2 memory 2 bytes ಇದಕ್ಕೆ ಬೇಕು. So third one 104. Now name of all these memory blocks is A itself. Okay, that is one thing which I am written. So here A is not called as normal variable, it is called as an array because for the same A, there are 3 memory blocks. That's why it is called as array, not normal variable. Apart from address and name, for these memory blocks, there is one more thing which we are going to use. That is what we call, that is what I'm showing here, these things, or these numbers. See, all these numbers are written within square brackets. So 0 within square bracket, 1, here it should be 2 here, it's not 3, please. 2, okay. So 0, 1, 2. So these numbers which are in a particular order, which are stored in square bracket, are called as index values of each memory block. So index value of first memory block is 0, index value of second memory block is 1, index value of third memory block is 2. These are all very important for a particular array here, okay, for a particular array. Now, consider one more example. So if I write int a of 5, what computer will do is it will create 5 continuous or 5 group of memory blocks, group of 5 memory blocks. Okay, name of all the memory blocks will be A itself. Address of all these memory blocks will be different, but before address, each memory block will be having its own number within square bracket. So that is called as index number. So index number of first memory block is 0, 1, 2, 3, 4. So this is how index values are created. Apart from that, they'll be having address here. If the address of first memory block is 100, what could be the address of second one? Because of int 102, 104, 106, 108. This is what happens when you write this. And this is called what we call arrays in data structures or arrays in C programming language. Now we have created the memory blocks with some index values and with continuous address. And these group of memory blocks are called as consecutive memory blocks or continuous memory blocks because they have address which are connected to one another. Okay. Now how to store the values in these memory blocks? It's very simple. What I'm going to do is, instead of writing only this much, I'm going to write this one. Int a of 5. I remove the semicolon here. Instead of semicolon, I'm going to write equal. Okay. Within the flower bracket, I'm going to write some numbers. How many numbers I should write? The numbers which I'm going to write they depend on the value or number of memory blocks which I am creating for A. How many number of memory blocks which I am creating for A? 5 memory blocks. So when I write this much here, what computer will do is, first thing what will do is, it will create 5 continuous memory blocks. Name of all the memory blocks is A itself. Okay. After creating the memory blocks, it finds equals here. Okay. It goes to the right side of the equals, and in the right side, it will find values in flower brackets separated by comma, 5 values. So it will take the first value and it will store first value in the first memory block of the array A. First value in first memory block. Okay. So similarly, it will take the second value, it will store that second value in the second memory block, which has the index value 1. Same thing happens with third value here, fourth value, and fifth value. So this is how you can create an array. At the same time, you can store the values in an array. At the same time, you can store values in an array. So this is what arrays is in data structure. Okay, this is how we create array, how we store values in an array. Okay, after that, imagine that you have stored all these values 17, 18, 7, 26, and 27. Now, once these values are stored in the memory blocks here, how to display these values on the output screen. Output screen li ee values na yav tara display ಮಾಡ್ತೀರಾ? Single memory, if it was a single memory block, you would have written printf percentage d a. You would have written printf percentage d a. But here, because there are many memory blocks with the same name of all these memory blocks is a itself. If I write printf percentage d a, computer goes to this particular place and it finds that name of all these memory block is a itself. It will get confused which memory blocks value it has to display. So the name of all the memory blocks is a. What is the solution for this? Solution for this one is, okay, apart from index values, there are address here. Instead of this writing like this, I'm going to write this one, okay, this line, and I want you people to analyze now. Printf percentage d a of, within the square bracket I'm writing 0, a of 0. I'm going to read it as a of 0. When I say a of 0 here, computer goes to a memory block called as a and it tries to find 0 index value. And 0 is the index value of which memory block? 0 is the index value of first memory block. Okay, that's why computer goes to this particular memory block. It takes the value which is stored in this memory block, and that value is displayed on the output screen. 17 will be displayed. But only 17 gets displayed here. If I have to display all these values, 17, 18, 7, 26, 27, what should I do? What I'm going to write is I'm going to write this one. Printf percentage d, percentage d, percentage d, percentage d, percentage d. That means I'm displaying 5 integer values. Why 5 integer values? Because size of the array is 5. This 5 is called as size here. Size of the array 5 idre 5 memory blocks irutte. 5 memory blocks alli 5 values store madidira. That's why I'm writing percentage d, percentage d, percentage d, percentage d, percentage d. Now for first percentage d, I'm writing a of 0. So computer easily goes a. It goes to the index value 0, it takes the value 17 and will replace percentage d by 17, and that will be displayed on the output screen. Then how to display second value 18? I'm going to write it as a of 1, a of 2, a of 3, a of 4. So it will display 17, 18, 7, 26, 27 on the output screen when I write this particular printf statement, not this one or not this one, this one. Okay, but the problem here is, if there are 20 values stored in 20 memory blocks, I should be writing percentage d 20 times, and I have to start with a of 0. I have to end with some index value here. So printf becomes longer. It means it takes time to write those many characters in the printf statement. So that is not, so though it is displaying the output here, this is not the right way of displaying all the values. See, values which you have stored here are called as elements of an array. We'll store ಮಾಡಿರೋ values na ಏನಂತ ಕರಿತೀವಿ? Elements of an array ಅಂತ ಕರಿತೀವಿ. So to display all the elements of the array, I need to write so many things here. How to avoid this, or how to shorten this? Okay, instead of writing this, how to avoid writing so many characters? How to write it simple so that it'll display all the values or all the elements of an array? So for that, we are going to see here how to avoid this. So observe this one. You know what happens in the memory block when I write this? Automatically this thing happens. Index values will be there. Are people concentrating? Hope you people are concentrating on DS subject itself, nothing else. Like you're watching the same screen which I am presenting, either in your mobile or laptop. Try to concentrate. Memory blocks create ಆಗುತ್ತೆ, ಅದರಲ್ಲಿ values store ಆಗುತ್ತೆ, index values assign ಆಗುತ್ತೆ, then address. Okay. So see, these index values are not referred by the computer. It is our imagination. Index values here. Only address is decided by the compiler or the computer. So I'm going to write one more variable here called as int I. So I and the memory block create ಆಗುತ್ತೆ initially. So okay, now how to display all the elements of the array without using the previous method? Like, what was the previous method? What was the previous method where we had written this much? So without using that method, how to display the elements? So let's see how to display the elements without using previous method. We can use looping statement to avoid writing so many characters in printf statement, writing so many percentage d, writing so many index values in printf statement. I can use, or I can write looping statement. Now, how to write a looping statement, what kind of looping statement is important, and what kind of values we have to use in the looping statement, that I'll explain. So major looping statement which we use always is called as uh, for loop. Okay, for loop use ಮಾಡಬಹುದು, for loop, or you can use any other looping statement, but I am going to use for loop here. Now observe here, I have declared a variable called as I. Within the for loop, I am going to write I is equal to 0. So automatically 0 will be stored within the memory block here. I'll tell you why we are storing I is equal to 0. Then I'm writing I less than 5. I hope you people know why we are writing this condition. Okay, I'll tell you that also soon. Then I plus plus. So this is the first part of the for loop. I'm going to write the statement block of the for loop. Statement block ಅಂದ್ರೆ opening ಮತ್ತೆ closing flower bracket ಅದರೊಳಗಡೆ ಏನು ಬರೀತೀವಿ ಅದು. So opening flower bracket ಬರ್ದಿದ್ದೀನಿ. Okay, printf percentage d. See, only 1% d I'm writing here, though I have to display so many values. I'm writing only 1% d, unlike the previous printf statement where I had used so many percentage d. Okay, after percentage d, I'm going to write a of 0, a of 1. What I'm going to write here is a of I and the breathing square bracket. Now observe this one, this printf statement. Let's start from for loop again. For what is the value which I'm storing in I? 0. Why I'm storing I is equal to 0 or 0 in I? Because the first number which I'm going to display is 17. Okay, and the index value of that first number is 0. That's why I'm taking 0 here. Now I is equal to 0, I less than 5. We'll check the condition. What is the value of I? 0. 0 less than 5. Condition is true. What happens when the condition is true? Computer enters, or compiler enters into the statement block. It will execute this printf statement here. Printf percentage d, a of, within the place of I, computer takes the value of I. What is the value of I? 0. So a of 0 on the. What is the meaning of a of 0? Computer goes here, a, it goes to an index value called as 0. It goes inside that particular memory block. It takes back, it brings back that 17 here. It will display 17 on the output screen. So first number display to 17. After executing this line, computer will go back to the place of increment part of for loop. Increment part ಗೆ ಹೋಗುತ್ತೆ, for loop in increment part ಗೆ direct ಆಗಿ. Okay, so what happens here in the increment part of the for loop? I plus plus, I have already explained. I plus plus ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? Value of I gets incremented by 1. So what should happen here? Value of I, so 17 already display ಆಗಿದೆ ಇಲ್ಲಿ. Value of I ಏನಾಗಬೇಕು? 1 ಆಯ್ತು. From 0 it has become 1. Okay, now after incrementing the value of I, computer goes to the condition part here. It will check the condition again. What is the latest value of I? Latest value of I is 1. So 1 less than 5. Condition is still true. Because the condition is true, it enters here. It will execute the same printf statement again. Now tell me, what are the changes here? Printf percentage d, a of, what is the latest value of I? Latest value of I is 1. So a of I and a of 1. So it goes to a, it goes to the index value, that is 1. It enters into the memory block. It gets the value 18 back here, and the 18 will be displayed on the output screen. 18 will be displayed on output screen here. Okay, so after executing this line again, computer will again go back here. I have already explained how many times for loop executes. ಎಲ್ಲಿ ತನಕ ಎಷ್ಟು ಟೈಮ್ ಫಾರ್ ಲೂಪ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುತ್ತೆ, ಎಲ್ಲಿ ತನಕ ಕಂಡೀಷನ್ ಟ್ರೂ ಇರುತ್ತೋ ಅಲ್ಲಿ ತನಕ ಫಾರ್ ಲೂಪ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ. ಅಂದ್ರೆ ಕಂಪ್ಯೂಟರ್ ಒಳಗಡೆ ಹೋಗಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡ್ತಾನೆ ಇರುತ್ತೆ ಇದನ್ನ. ಯಾವಾಗ ಈ ಕಂಡೀಷನ್ ಫಾಲ್ಸ್ ಆಗುತ್ತೋ ಅವಾಗ ಕಂಪ್ಯೂಟರ್ ಎಂಟರ್ ಆಗಲ್ಲ ಇಲ್ಲಿ, ಇಟ್ ವಿಲ್ ಜಸ್ಟ್ ಸ್ಕಿಪ್ ದಿಸ್ ಪಾರ್ಟ್. ಓಕೆ, ನೌ when it goes back here, I plus plus ಅಂದ ತಕ್ಷಣ I ವ್ಯಾಲ್ಯೂ 2 ಆಗುತ್ತೆ. ಕಂಡೀಷನ್ ಏನಾಗುತ್ತೆ? I less than 5, 2 less than 5. Condition true. Again it enters here, it will execute printf statement. A of I, what is the latest value of I here? 2. A of 2, which one? A of 2, 7. So 7 will be displayed. What happens after this one? It will go back here, it will increment the value of I. So value of I has become 3. 3 less than 5. Condition true agate. Again it enters here, printf percentage d, A of I value is 3. So A of 3, the value in that third index value is The third index value memory block value is to 26. So 26 will be displayed. It will go back again. Value of I becomes 4. Okay. Condition 4 less than 5. Condition is true. It enters here. Printf percentage d a of 4. Okay. A of 4 and this index value. E memory block e index value memory block idu. The value is to 27. So 27 will be displayed on the output screen. Now auto once again it will go back here. I plus plus. I value becomes 5 here. 5 less than 5. Condition false. Condition false. So what happens when the condition fails? It won't enter here. It will just skip the statement block. Statement block and opening with closing flower packet and all the statements which are written within opening and closing flower packet. So it will skip this part. It will go to the next part of the program. So by that time, it would display 17, 18, 7, 26, 27, which are all the elements of this array here. So this is how you can print the elements of array on the output screen. Ee tara array liro elements na output screen alli display ಮಾಡಬಹುದು. Okay, so this is what arrays is. Array ಅಂತ ಹೇಳಿದ್ರೆ ಈ ತರ ಇರುತ್ತೆ. Arrays ಅಲ್ಲಿ ಈ ತರ elements na store ಮಾಡಬಹುದು. Array elements na ಈ ತರ display ಮಾಡಬಹುದು output screen ಅಲ್ಲಿ. If you have to display elements of the array, you have to use for loop. See, there is some lab program I think Sankhya madam has already done based on arrays itself. Okay, so in that program also there are some cases where we use for loop. We will store the elements in the array. We will add some elements in between. See, you must know how for loop is very important in terms of arrays. How you can use for loop and how for loop gets executed to display elements of the array or to store the elements in an array or to display a particular element and all. Okay, that we'll also see soon, how to store elements in an array. So hope you have understood this part here. Okay, this part of the program. So this is a basic part of the array. So let's see one more example. See, before writing this for loop, I can write a printf statement here, so that before it displays all the number which is using for loop, it will display some message also like this. Array elements are 17, 18, 7, 26, 27. So this is how you can write the program for arrays. You should know why you are writing I here. What is the major role of this variable I? I is majorly used to indicate index values of each memory block whenever it is required, like that. Okay. So let's see one program here which I have already explained. It's a question for that program. Write a C program to declare and initialize an integer array of size 5 and display all the elements of the array. You have to declare and initialize like this. What kind of array? Integer array. Array name ಏನು ಬೇಕಾದರೂ ತಗೊಳ್ಳಿ. Size ಎಷ್ಟು ಹೇಳಿದ್ದಾರೆ 5. Declare ಮಾಡಿ, then initialize ಮಾಡಿ. This is the initialization part. Okay. And display all those elements. Initialize ಆದಾಗ elements ಅಷ್ಟು array store ಆಗುತ್ತೆ. Okay. After that you have to display all the elements. To display all the elements of the array, we need for loop. Whenever we use for loop, we need a variable called as I. Store I is equal to 0. You know why we are storing I is equal to 0? Because we have to start displaying elements from the first element of the array, and index value of the first element of the array is 0. That's why. Okay. I less than 5, I plus plus. It will keep on displaying all the elements of the array. Okay. This is the program, first program of arrays. Let's check one more program. Write a C program to declare and initialize a floating point array of size 5 and display all the elements of the array. Instead of integer array here, we have to create a floating point array. Okay, floating point array ಅಂದ್ರೆ array floating point values na store ಮಾಡ್ತೀರಾ and display all the elements of the array. So first line, second line, third line. Instead of int a, I'm going to take it as float a. ಯಾಕಂದ್ರೆ memory block create ಆಗಿರೋದು floating point memory blocks create ಆಗಬೇಕು, so that they can store only floating point values. After declaring this one, you're going to write this 17.1, 18.1, 7.1, 26.1, 27.1. All these values get stored here. Index value, floating point array ಆದ್ರೂ ಅಷ್ಟೇ, integer array ಆದ್ರೂ ಅಷ್ಟೇ, index value will still be same. Okay, 0, 1, 2, 3, 4, depending on size of the array. If the size of the array is 5, last index value will be 4. Okay, array size -1. Remember this. And address also, integer or hexadecimal values will be there for address. Here I'm showing integer numbers. Now, how to display these numbers? Again, to display these numbers, I need for loop. I need a variable called as I. I will still be int itself because I represents index values 0, 1, 2, 3. That's why. Okay. For I is equal to 0, again the condition is I less than 5 because the last index value is 4. I gets incremented every time from 0 to 4. That's why I less than 5, I plus plus. Within for loop, printf percentage d ಬದಲು percentage f use ಮಾಡ್ತೀರಾ. A of I, it will still be same. Initially value of I 0 ಇರೋದ್ರಿಂದ a of 0 ಹೋಗುತ್ತೆ. a of 0 ಏನಿದೆ 17.1, that will be displayed on the output screen. ಅದೇ ತರ 18.1, 7.1, 26.1, 27.1 will be displayed on output screen. Okay, this is one more example of arrays. Let's see one more example or one more program on arrays. Write a C program to read 5 integer numbers for an array and display all the elements of the array. Okay, this is the last program which I'm going to explain. In a minute, I'll explain. Okay, be there. It'll take only 2 minutes. See, only difference here you should observe here is declare and initialize badlu. What they are saying is we have to read 5 integer numbers. We should not decide the numbers here or elements of the array. We have to ask someone to enter the numbers. Okay, so what kind of array? They have not mentioned, so I can decide by myself here. So integer array. Okay, let's change it. I'm taking an integer array here. Just observe int a of 5 memory blocks are created, integer memory blocks with index values and address. Int I, you know why we need this variable, because of index values. Instead of writing a of 5 is equal to some values here, what I'm going to do is I'm going to write a printf statement, enter 5 integer numbers. This will be displayed on the output screen. Okay, so user will enter 5 integer numbers. See, there is a method I can use to read all those 5 integer numbers and store those 5 numbers in 5 memory blocks. I can write a scanf. Scanf ಆ ಕೆಲಸ ಮಾಡುತ್ತೆ 5% d ampersand a ampersand a ampersand a ampersand a ampersand a. But the problem here is, as soon as I write ampersand a, computer gets confused because all the memory blocks has same name a and different address here. So there will be a confusion if I write like this. So I cannot write like this. So what is the problem, or how to solve this? So instead of writing this, I can write this one, this line, percentage d percentage d percentage d percentage d ampersand a of 0. Now it is okay. Ampersand a of 0 andre a of 0 and that address, in that address first value entered by the user will be stored. Similarly, ampersand a of 1, ampersand a of 2, ampersand a of 3, ampersand a of 4. But the problem here is, again, if user enters 10 numbers, I have to write 10% d and I have to start with ampersand a of 0 till ampersand a of 9. So again, it takes too much time to write this. So what is the solution? Same solution which we have used for displaying the numbers. What is that? Using for loop. So just observe here. So this is the first method of storing the values and displaying those values on the output screen. So this is not valid, though it is okay. It's not a right way of storing the numbers in an array. So there is one more program for that. It takes some time. So hope you are understanding. Please do let me know whether you are finding it difficult while I explain programs and all, because I don't know. If you people don't respond, I'll believe that you people are getting everything, or you people are not getting anything. There are only two guess I can do. One is ಎಲ್ಲ ಅರ್ಥ ಆಗ್ತಿದೆ, ಇಲ್ಲ ಏನು ಅರ್ಥ ಆಗ್ತಿಲ್ಲ. If you are not understanding anything, you people have to let me know. If you are understanding everything, then also do let me know about that. Okay, so let's stop today's class now. All of you enter your USN and name and do attend next class as without miss. Have a great day.